Hello friends, Mr. Burrell here. We're in the unit talking about circles, and we're going to introduce this next topic titled equations of circles. So we've talked in the past a lot, especially this trimester, about equations of quadratic functions. We've talked about equations of linear functions in the past. We've talked about lots of different types of equations. Today we're going to talk about circles and what the equations of a circle look like. So by the end of this video, this is what I hope you're able to do. I hope you're able to identify the radius and the center of a circle from its equation in standard form, and write the equation of a circle given its center and radius in multiple formats. Okay, so that's what I hope you're able to do by the end of this video. So here I'm going to draw a quick sketch. I'm just going to draw a rough general circle here. This right here is the equation of a circle in standard form. Looks kind of big, looks kind of long, there's a lot going on, but it's not as menacing as it might seem. Let me read this out. This is x minus h in parentheses squared plus y minus k in parentheses squared equals r squared, where h, k, and r are just numbers. So some things to remember, some things to note about the equation of a circle in standard form. The negative here, this minus sign means opposite. So when I tell you that HK is the center of the circle, say I had x minus 2 squared plus y plus 3 squared, then the center of the circle would be at 2, negative 3. The x-coordinate is the opposite of this number, and the y-coordinate would be the opposite of this number. You've heard me say in the past, when we were talking about quadratics, for example, or other types of functions, that the number inside the parentheses was opposite, or it was the opposite of the sign that was given, something like that. That same kind of a principle applies here. So this number right here, the opposite of that number, becomes the x-coordinate for the center of my circle. The opposite of this number here gives me the y-coordinate for the center of my circle. So the center of this circle would be at 1, 2 in the x direction, 1, 2, 3, negative 3 in the y direction. And then r would be the radius of this circle. This r value is the radius of this circle here. And notice how it's squared. So if I gave you something like x minus 2 squared plus y plus 3 squared equals 4, then the radius would be 2. Because this number over here on the outside of the equal sign, on the right side of the equal sign, is r squared, so the radius is going to be the square root of that number. So the radius of my circle here would be 2, which means, let's see, I go 2, my radius goes 2 in every direction, so my circle would look something like that. That was a really bad drawing, but my circle would look something like that, with a center at 2, negative 3, and with a radius of 2. So that's the equation of a circle in standard form. Real quickly, I want to show you something. I've pulled up a little Desmos applet, and feel free to pull up Desmos and experiment with this on your own. But right here I have the equation x squared plus y squared equals 1. And that's this circle. X squared plus y squared equals 1. I'm not adding or subtracting anything to x, so the x-coordinate of the center is 0. I'm not adding or subtracting anything to y, so the y-coordinate, of the circle, center of the circle is 0. So right here at 0, 0 then is the center of my circle. And on the right side of the equal sign here I have 1. The square root of 1 to give me the radius is 1. So my radius in all directions here is 1. So note, up here I have the standard form of the equation of a circle. X minus h squared plus y minus k squared equals r squared. And I've made little sliders to change the value of h, k, and r. So notice what happens when I change the value of h. When I bring h up here, so like when h is 6, that would make this equation x minus 6 squared. That means that the x-coordinate of the center now is at 6. So this h value changes the x-coordinate of the center, moves it left to right there. My k value, this y minus k, notice what happens when I move this slider for the k value in this equation. Yes, indeed. It moves it up and down. So like right here, for example, when k is equal to 4, that means this part of the equation would be y minus 4 squared. The opposite of a minus 4 is a positive 4, so the y-coordinate of that center point of that circle would be 4. So that k value changes the center of the circle. And this r value, notice in my equation I have r squared, so as I change this r value, notice what happens to the circle. This radius becomes larger. So like right here, when I change r to be 5, that means the radius of this circle is 1, 2, 3, 4, 5 units. And in this equation, r squared would be 25. If I move this, I don't know, to 7, so the radius would be 7, that means this value on the outside of the equal sign would be 7 squared, or 49. So I can kind of, change this a little bit as I go along, kind of change my h and k and r values to give me different sizes of circles placed in different locations around my graph. I'm kind of spinning around in a circle here. That's kind of fun, talking about circles. So that's the standard form of the equation of an equation of a circle, and that's how you can kind of interpret and create a graph of a circle based on that equation. Okay, so let's go back in here real quick. So let's look at some examples. So these are some examples of some problems you might see on the homework. So this says identify the center and the radius from the equation. So real quick, I'm going to go ahead and write my standard form of the equation of a circle. X minus h squared plus y minus k squared equals r squared. So h, again, is going to give me the x-coordinate of the center of the circle. K is going to give me the y-coordinate of the center of the circle. This is the center. And then r is going to give me the radius. So I want to find the center of the circle and the radius. So the center of the circle here, what's the center of the circle going to be here? Well, I need to take the opposite of this number, which is a positive 9, the opposite of this number, which is a negative 11. X-coordinate, y-coordinate. So the center of this circle is 9, negative 11. And the radius of this circle is going to be the square root of this number, because that number right there is r squared, so the radius of that circle is going to be the square root of 16, which is 4. So this circle is centered at the coordinate 9, negative 11, so it's going to be like 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 11. There's going to be a circle down here with a radius of 4. That's approximately what that circle would look like. Okay. Number 2 over here, so we need to find the center and the radius of this circle. The center of this circle is going to be the opposite of this value and the opposite of this value, so 1, negative 10. So that center of that circle is at 1, negative 10, and the radius is going to be the square root of this number. The square root of 4 is 2. So that's a circle with a center at 1, negative 10, and with a radius of 2. What's the center of this circle? Well, the center of the circle is going to be opposite of this number, and then the opposite of this number. So the center of this circle is going to be at negative 3, negative 15, and the radius is going to be the square root of this number. So the square root of 1, which is 1. Okay, one more here. Oh, whoops, let me go back. One more here. I'm trying to find the center and the radius. The center of this circle is going to be the opposite of this number and the opposite of this number. So at the coordinate 15, negative 6. And then the radius is going to be the square root of this number. The square root of 6 is like 2.45. So the radius of that circle is almost 2.5 units. So that's how I identify the center and the radius of a circle given this equation of a circle in standard form. Okay, what if I give you the center and the radius and I want you to write the equation? Well, remember, the center I write as h comma k and the radius is r. And keeping in mind the standard form of the equation of a circle, x minus h squared plus y minus k squared is equal to r squared, I can kind of fill in the blanks here and write what the equation of this circle would be. So I'm going to have my x part, I'm going to have my y part, and I'm going to have my r squared part. So let me fill in the blanks here. So remember, it's going to be, if the center is -6, -1, the values in here in the parentheses are going to be the opposite of those. So right here, I'm going to have x plus 6 and y plus 1. It's the opposite of these numbers. -6 turns into a +6, -1 turns into a +1 for the equation of the circle. And the radius is going to be this right side of the equal sign is going to be r squared, or 4 squared, which is 16. 4 times 4. So the equation of that circle with a center of -6, -1, and a radius of 4 is x plus 6 in parentheses squared plus y plus 1 in parentheses squared equals 16. Okay, let's do this one right here. So, again, my equation is going to look something like this. An x in parentheses squared with a y in parentheses squared equals r squared. So the center is at 15, 5. So this is going to be x minus 15 and y minus 5 because it's the opposite. What's in the parentheses here is the opposite values of what the coordinates for the center of my circle are. And since my radius is 3, that means over here on the right side of the equal sign, I'm going to have 3 squared. 3 squared is also equal to 9. So that would be the equation for that circle, centered at 15, 5, and with a radius of 3. Okay, down here for this circle, number 7, I'm going to have x in parentheses squared, y in parentheses squared, where my coordinates in here are going to be the opposite of the coordinates here. So I'm going to have x plus 1 and y minus 1. And over here on the right-hand side, I'm going to have r squared, or 13 squared, which is equal to 169. So that's the equation of this circle, centered at -1, 1, with a radius of 13. This last one, number 8, the equation of my circle is going to look something like this, with x in parentheses squared, x in parentheses squared. This is going to be x plus 15 and x plus 8, because these values are the opposite of these values, with a radius of 3 makes the right side of my equal sign 3 squared, which is also equal to 9. So that right there would be the formula for the equation for that circle, with the center at -15, -8, and with a radius of 3. Okay, let's look at one more type set of questions. So what if I give you the graph? What if I give you the graph of a circle and I want you to write the equation? Well, let's look at this. In order to write the equation of a circle, I'm going to need to know the center of the circle, and I'm going to need to know the radius of the circle, because remember that the formula for the equation in standard form of a circle looks like this, where h and k represent the coordinates of the center of the circle, and r represents the radius. So let's see if I can find the center of the circle and the radius. So here's the center of my circle. Looks like that's at -3 in the x direction and 3 in the y direction. So the center of the circle is -3, 3. Well, that's good. That's part of the information that I need. Now I need to find the radius, or the distance from the center of the circle to the outside of the circle. And it's going to be easiest to find this radius either going straight up or down, or straight left or right. So for example, going from -3 all the way to +3 here, that's a radius of 1, 2, 3, 4, 5, 6. Same here, 1, 2, 3, 4, 5, 6. My radius is 6. So I can go ahead and fill in my blanks here for the equation of a circle. So this is going to be x plus 3 squared and x minus 3 squared, because the x-coordinate is -3, so this turns into a +3. The y-coordinate is +3, so it turns into a -3. And on the right side of the equal sign here is the radius squared, or 6 squared, which is equal to 36. So that there is the equation for that circle. X plus 3 squared plus x minus 3 squared equals 36. Okay, number 10 here. Let's find the center and the radius of this circle. The center here is right here, which looks to be 2 in the x direction, 1, 2, 3 in the y direction. So 2, 3. And then the radius seems to be 1, 2. 1, 2 units. So the radius is going to be 2. So the formula of my circle, the equation for my circle is going to be x minus 2 squared plus y minus 3 squared equals 4. Negative 2 because it needs to be opposite of the x coordinate. Negative 3 is opposite of the y coordinate. And 4, this number on the outside of the equal sign, is the radius squared, or 2 squared. Okay, last one. The center of this circle is at 3, negative 5. The center of that circle is at 3, negative 5. The radius of this circle is 1, 2, 3, 4. Yep, 4. So the radius is 4. So the equation of this circle is going to be x minus 3 squared plus y plus 5 squared, in parentheses, both of them, equals 4 squared. 4 squared is equal to 16. So the equation of my circle is x minus 3 squared plus y plus 5 squared equals 16. Okay, and that's all I've got for you in this lesson. Hopefully now you're able to identify the radius and center of a circle from its equation in standard form, that h and k values and the r values. And hopefully you're able to write the equation of a circle given its center and its radius, whether I give you the center and the radius in the straight out, or if I give you a picture of a circle and have you identify the center and the radius. Hopefully you can write the equation of a circle given that information. So I hope that was helpful. Please reach out to me if you have any questions whatsoever, and I hope that you enjoyed that as much as I did.